Hello everyone, True Zero Emissions here. Okay, so I just want to share with you just briefly, and watch this turn into a long video. This video should only be a few minutes, hopefully less than 10. But if it goes longer, then there must be more to say than I realize. We spoke the other day, I shared with you the other day about this bicycle light generator, right? See this? If I can get the phone to focus. And notice how the rotor inside here, 4 norths, 4 souths, as this rotates, it intermittently, it switches the 2 sets of what I'll call metal right now. There's 8 of these arms that come out, right? 4 of them are connected to this side, and 4 of them are connected to the inside. But what's happening here, essentially, is that this coil is being pulsed with a south on one side of the coil and a north on the other side of the coil at the same time. And that's because the magnets are north, south, north, south, north, south, north, south, north, south, right? So all the norths will be touching this side, and then when it turns, when the rotor spins, all the norths will be touching this side, right? These pieces of metal. And then it spins again a little bit more, and then it touches this side. So what that results in is this coil in the middle being pulsed with north, south, north, south, north, south on one side of the coil, and then north, south, north, south, north, south on the other side of the coil. And it's the opposite. So when this side's pulsing with north, this side's pulsing with south. Okay, now the reason I'm making this video right now, in part, is because I was remembering if I have another generator here. Who remembers this? This goes way back. Gerard Morin was experimenting with this, and he spoke highly of this. This is a motor, but Gerard Morin was using it as a generator. But let's look what's happening here. So what I did to this, all I did was change what was a bushing in here into a bearing. And I found the bearing from a remote control motor, okay? Made for like 1/8 scale, 1/10 scale electric motor RC cars, remote control cars. So I connected that to a motor here, which is a blender motor, and I connected the blender motor to the metal piece that comes out of here, the shaft. But let's look at the similarity. Now, what's the similarity between this and this? Look how much more wire we have here. Look at all that wire. This thing produces like hundreds of volts. Hundreds of volts. The rotor is inside here, okay? Now I'm trying to remember. I will have to check. I might have to open this up and check, but if I recall correctly, one side of the rotor is north and the other side is south. And let me just turn this by hand and see how it feels. So I'm going to turn this, so it's hard to turn here, and then it moves to this side. So then it's hard to turn here, and it moves to this side. That's 180 degrees. That makes me think that there's just 2 polarities here, a north and a south, right? That's what that makes me think, just how that feels. It's not turning, it's not becoming easy, hard, easy, difficult, and then easy, and difficult and easy, as like this, like intermittently, like that, like hard, difficult. I mean, difficult, easy, difficult, easy. It's just more like 180 degrees, right? One, and then it goes here, and then it goes here, then it goes here. So I'm guessing that it's probably becoming easier between here, because the metal's here, right? Unless it's attracting that metal. I don't know if it's attracting that. So it's probably here, and then here, right? Like that. And what's happening here is the coils, this metal goes all the way up to here, and these coils are wrapped around this plastic or some kind of non-metal material. And that rotor is like polarizing this, I'm gonna call it polarizing this metal. It's a ferrous metal, right? And that polarization is switching. So we'll call it north, south, and then south, north. North, south. Wait, north, south, south, north. North, south, south, north. It's switching these. This is becoming north, south, north, south, north, south, north, south, north, south, north, south. Right? As this spins, and these are opposites, right? Because when it only has a north on one side of the magnet in there and a south side on this side. Oh, what I changed on this, I'm just remembering now. It was a Castle Creations. It was called Castle Creations. This might be it right here. This is it. This is the actual casing for the motor. See this? So the motor came apart. It broke. But I used the rotor out of it. This is the actual rotor, the motor that the part came from. Look what it says, 100,000 RPM. See that on top? 100,000 RPM max. Isn't that beautiful? That means the bearing can handle that. Okay. What else does it say? Does it say anything else? Let's add some more light here. See if we could read anything else on this. (1410) 1Y 3800 kV 12 NIMH forward slash 3S, which is lipo, 3 cells in series, right? So it's 3 times 4.2 volts. Lipo max. So it's saying not to put more than 3 cells in series, which is, or wait. Oh, it's saying 12 cells of nickel metal hydride or 3 cells of lithium polymer, which is, let's see, 3 times 4 is 12. 0.2 times 3 is 0.6, so it's 12.6 volts maximum. But that's putting into this, right? What we're doing is different, because this is a motor here. But here, I took the rotor out of there, which is a powerful neodymium magnet. If I recall correctly, it had north on one side and south on the other, similar to the original rotor that was in here, which I actually have right here. I'll show it to you. Here's the original rotor that was in there. That was inside the inside this motor here. Now this is a dishwasher motor. Okay, this is a dishwasher water pump motor. I think it's the drain pump that drains the water out. That's what this is. This is actually a motor, but we're using it in this instance as a generator, right? Or possibly a battery charger, because that's what I'm doing right now. I'm thinking, remember I said in the last video, and we're already at 9 minutes and 21 seconds. You know what? I'm not going to look at the time. I'm going to focus on just communicating with you what I need to say, okay? So let's explore this together. All right, let's do this. I was saying previously that I want more copper and I want a larger version of this. And I thought, what do I have already, or what can I find in the world that already exists? And I remember this tonight, around 8 p.m. at night. I remembered I had this. And I said to myself, let's see what we can do with this. Now, I don't know what's happening in here, like right here. I don't know if there's like a resistor in there or what's happening in there. I don't know if there's any kind of anything in here. I don't know what's in here. I don't know what's happening in here. Is it just two coils connected together? Like it winds around this and then it goes over here and winds around that. What's happening over here, right? Because there's something here. Let's see if I can get this to focus. Can I get this to focus? See, there's a wire that comes up. It looks like a wire comes up to this. Let's see. Let's see if I can get some light on this. Let's see. Yeah, that definitely has a wire on it. What am I looking at? Okay, so when I'm using this, there's my two connections right there. Is these two. This one and this one, right? And what's interesting about this is it doesn't shock a person, but it's putting out 400 to 500 volts. Now, if you test this, please be careful. My recollection is that it doesn't harm us if we touch it, which is very interesting, right? It's like, what kind of energy is this? How could it not shock me at 500 volts? And is it because it's just milliamps of power? And is it milliamps, right? Is it actually milliamps, or is there some current in there? But I'm not looking for amperes right now. I'm looking for just what does the battery do? What does the voltage do of the battery? That's what I'm looking at. It'd be nice if I could put the light on this. I'm gonna see if I could get some more light here. Okay, anyway, this is a rotor I had that was in it, and I put a neodymium rotor in there. Let's just check the polarity of this and see if it is in fact north on one side and south on the other. Okay. That's that. So we're going to roll this over. Okay. Let's see how I can do this. Okay, it's definitely north on one side, south on the other, or we can call it plus and minus. So the neodymium magnet that I placed in there is rated for 100,000 RPMs, which is beautiful, right? Because I don't think this can go 100,000 RPMs. This was initially made to turn at very low RPMs. It was a water drain pump in a dishwasher, right? And I just looked for the largest one I could find that was the largest pump that I could find on Amazon, and I don't recall what the exact model was. If I can find that, I will post a link to it. But that's just showing you what I found. I mean, there's probably larger ones, right? And there's probably much larger motors in this, much larger, that exist for other, other uses, right? That have this kind of design where the metal comes down. There's plastic or some kind of non-metal material between the rotor and the metal here. Okay, there's two. You're looking at two bearings right here. You can't see it, but there's two bearings there. See the rotor inside there? It's inside there. And I may be able to turn that so you could actually see it turning. Yeah, see that turn? See that? Very important to have a bearing there, because that bushing would not last long that comes in there. It's not made for high RPMs, for fast spinning. So what happens if I put this on a scooter, run it into a full wave bridge rectifier, and then into my battery, and just watch the voltage very carefully, right? Then what happens if I put a spark gap? Let's say the spark gap would have to go, I think the spark gap would have to go between the full wave bridge rectifier and then maybe into a capacitor and then into the battery, right? That's just an idea, a thought experiment. But just try different things, because what does the spark gap do? and I don't, at the moment, I don't actually recall, but maybe does it increase current? I mean, remember, space has megawatts of energy in it. So if we have a spark gap, what happens when energy jumps across that area, right? Think about our automobiles. There's a spark gap, and there spark plugs have spark gap, right? And we adjust them to just the right certain amount. And that helps ignite that fuel, right? That highly processed fuel, highly processed, to be able to be burned in the cars. And today was a terrible, terrible day of smelling cars that were just starting up, and the catalytic converters didn't have a chance to warm up enough to burn that unburnt fuel, and it was just going right out the exhaust, and it smelled so bad because we were outdoors tonight, right? That's what we were doing tonight. We were outdoors, and we all had to smell that smelly, smelly cars. It's really bad to breathe that too. That's why in about just over 1 year from now, in 2025, if I recall correctly, gasoline cars were scheduled to be outlawed in California. No more selling new gasoline cars. That was pushed back a little bit, but there's no need to wait for the new date. We could just switch over to the non-gasoline petrol fuel systems, which is electric, anytime we want. It's our choice, right? We can just switch over. And I think people are doing that. So most people are doing that. So that's great. And then then as the grid gets cleaner and cleaner, as they say, the cars are cleaner and cleaner, right? But even if 100% of the energy came from coal, which it doesn't, it still pollutes half as much as running a gasoline-powered petrol car. If you're running an electric car off just coal-powered electricity. So it's half the pollution, okay? Because a lot of people want to know that. We're like, how dirty is the electricity, right? But then you also have options of solar, and people run off solar. They run solars on their houses, solar power, and things like that. So anyway, going back to this, I just wanted to share with you that I was realizing that I have this. Now I'm still interested in this. I'm still interested in testing this, but now I'm thinking, how could I mount this in place instead of that, this generator, right? Could I just mount this one and see what that does? Because what is this doing? We're pulsing the coils. This coil is getting pulsed with south, this one with north, and then north, south, south, north. It's switching at the same time, pulsing it, pulsing, pulsing, pulsing. And that reminds me of this. And also the drawings I was sharing with you in the last video of the G-Field generator, John Bedini's G-Field generator. And at least a portion of it, not the complete thing, not the complete G-Field generator, but at least like half of it. So just starting small and seeing where I can go with this and what happens when we connect this to a battery, right? Okay, everyone, True Zero Emission signing off here. Just wanted to share that with you, is that I already had something that I can use that may do something with the battery. I'm interested in what this does. I did notice that when I connected this to batteries in past tests, and this has been quite a while, so I'm not recalling at the moment those tests, all the details of it, but I do know that this likes to take the batteries up to full voltage, but not beyond. And I was really interested in that. It was allowing the batteries to go to full, but not overcharging them. But I would disconnect it once the battery's at full charge. I would not try to overcharge the battery. I wouldn't do that. I wouldn't let it go, let it keep charging. Once it's full, I would disconnect it. Okay, everyone, True Zero Emission signing off, and we'll see you in the next video. Have a great day. Bye.